Okay, so this is a MAT question, I believe from 2018. This is actually a blind solve, e.g., this is a question I have not solved before. And it's a good example of a question which is very typical for the MAT, which is just very bizarre and not, you could argue it's very difficult to prepare for. But the skill in solving these kind of questions is the same across all the questions. And it really is just dependent on just trust that the question itself is trying to help you, and just write out everything you can that they tell you, and just sort of translate what they're saying, and the answer should just fall out. So that's what I'll be doing when I solve this question. So first thing they say is that 10 children are seated clockwise in a circle from C0 to C9. So I'm actually going to very quickly write that out. Okay, so we've got our circle, and you've got a teacher walking clockwise behind the children with a large bag of sweets. She gives a sweet to child C1. So we've got the first sweet goes here. Then we go to there. Then we go to, so this is +2. Then we've got +3, and we give the third sweet out. Then we go +4 and give this fourth sweet out. Then we'll go +5 and give the fifth sweet out, etc. So why have I bothered drawing that on? Well, it's just so we can sort of understand what's going on. Okay, the kth sweet is given to child Ci. Explain why I is the last digit of the number k + 1/2. So already we've jumped into something that just seems to sort of jump out of nowhere, and it's this kind of thing in the MAT that can really act as a sort of paper destroying thing, where it's just a block and it feels very difficult to make progress. So what you want to do is you want to just, again, take a look and just sort of just start translating what they've given you. This should look familiar. This is the sum from 1 to k of the numbers. So that's 1 + 2 + 3 + ... + k. Okay. And so just looking at our diagram, well, it's relatively obvious that actually, so what is that? Well, that's the number of steps taken. Have a look at what what the teacher's doing. She's taken 1 step, then 2 steps, then 3, then 4. So when she's given out the kth sweet, she's done k + 1/2 steps. Okay, so we translated that. And when she's taken that many steps, well, which child is she on? Well, let's say she took, 7, 6, 4, 5 steps. Well, we know which child she's on. She's on child number 5, because the sort of, the child resets every 10. So it is just the last digit. And so effectively, we've done this this part of the question already, just by sort of understanding it. So we're saying that, okay, well, k + 1/2 steps, and child I resets every 10 steps. And so we've got that last digit of k + 1/2 is who receives kth sweet. There we go. So even that first bit, which seemed very strange, you can see sort of just writing it down and looking at the diagram, looking for clues, just translating it is how we get through it. Okay, let 1 be less than k less than 18. So that's already quite interesting. It's a weird range. Explain why the kth and the 20 minus k minus 1th suites are given to the same child. Okay, well, we've already done something that, like, we've just done this. And the questions are designed such as in a way that they're meant to help you. So in other words, well, K, so that's part I, and I, we just want to use the earlier part, ideally, and see how we can use it. So kth suite, so just translating it, kth suite, child, last digit of k plus 1 over 2. Fine. And then the 20 minus k minus 1, the sweet child, well, that's just got to be last digit of, well, 20 minus k minus 1, 20 minus k over 2, and if we if we expand that out, we get that that is equal to, well, 20 times 20. In fact, I'm gonna well, let's expand them both out. That's k squared over 2 plus k over 2, and this is 200. In fact, yeah, okay, 200. I'm gonna make this slightly easier on myself. This is 10 minus k over 2. So 200 minus 10k minus 10 minus another 10k plus k squared over 2 plus k over 2. Okay. And, well, now having a look at this, these are the same thing, except for this, right? As in, we've got k squared over 2, k over 2, k squared over 2, k over 2. And so what do we notice about this weird extra bit? Well, these are all multiples of 10, e.g., no effect on final digit. And so what we can say is that the final digit of both these numbers must be the same, which is what we needed to do. Whether or now it's interesting to ask, why does 1 have to be less than k less than 18? I don't believe this is part of the question, but it's just worth looking. I believe it's just going to be to do with the fact that we want 20 minus k minus 1 suite. So if k was, well, k can't be less than 1, that's obvious. But also if it was bigger than 18, then we'd be talking about the 0th suite. So that's all this means. Okay. Explain why the kth suite is given to the same child as the k plus 20th suite. Well, again, that looks extremely similar. So we know that the kth suite is given to the last digit of this. And so what's the kth plus 20th suite? Well, that's last digit of k plus 20, k plus 21 over 2. and just expanding that out again, we've got that equal to k squared over 2 plus 41k over 2 plus 210. Okay. And so what we want to do is, in a very similar way to how we did before, we want to make sure that we can extract this number out. And so if we write that out, we can say that that's k squared over 2 plus k over 2 plus 20k plus 210. That's this, the same thing. And again, this thing, multiples of 10, no effect on last digit. And so it's the same child. So you can see they are designed to look scary, but they're also set up to help you out. Okay. Which children can never receive any sweets? Well, okay, so again, it seems like it comes out of nowhere, but just believe that the earlier parts are designed to help you. So first of all, what you can see is that, well, this and this look somewhat linked, as in we've sort of dealt with 1 to 18, and then we've dealt with 20 onwards. And so what is this thing actually saying? Well, it's saying that part 3 is just saying pattern. You really want to understand what you've done every time. So pattern repeats after k equals, well, k plus 20. So after k equals 20. And so what does that mean? Well, if child receives no sweets for 1 less than equal to k less than or equal to 19, never receives sweets. Okay. But we also know that so what we could do in theory is just check which child receives which for 1 to 19. That sounds a bit annoying, but it would be viable. But we can probably use this. So apparently the k sweets are given to the same child as the 20 minus k minus 1 sweets. So that's actually going to streamline this a lot. And now it's just going to be a bit of listing out. So sweet child. And so we've got 1 and also 20 minus k minus 1. So 1 and 18, 2 and 17, 3 and 16, 4 and 15, 5 and 14, 6 and 13, 7 and 12, 8 and 11, 9 and 10, and then it will flip. So, and then we'll also have to deal with sweet 19 as well. So, so in other words, all I'm saying is that the same child received these sweets. And so, well, who gets, well, now all we need to do is list it out, and then we're basically done. So we've got, well, that's just child 1, that's child 3, that's child 6, that's child 0, just looking at a diagram, that's child 5, then we'll be at 15, so plus 6 is 21, so that's child 1, plus 7 is 28, so that's child 8, plus 8 is 36, so 6 plus 9 is 45, that's child 5. And then we also need to consider the 19th sweet because we've left that out. And so what can we say? Well, 19th sweet last digit of 19 plus 1 over 2, which is apparently just 190. So child 0. Okay, and so never receives any, because we've said that it repeats after 20, so never receives any will just be anything that didn't appear. So in other words, that looks to me like 2, 4, 7, and 9. Okay, and so you can really see that the questions, they're designed to make you sort of say, I have no idea, and sort of try random stuff, but you really do want to just use the earlier parts to help you. Okay, when the teacher has given out all the sweets, she has walked exactly 183 times around the circle and given the last sweet to C0. Well, so immediately that's actually very helpful, because we know that the number of times she's walked around the circle is the number of steps she's taken time divided by 10. So in other words, 1830 steps taken. And number of steps taken is k plus 1 over 2. So actually, a very easy part, we can say that 1830 equals k plus 1 over 2. In other words, 3660 equals k plus 1. Now, you could solve this as a quadratic. I would say it's easier to just notice that's very close to 3600. So if we actually literally just try k equals 60, that works. And that's going to be the only answer. So it's k equals 60. That's how many sweets there were. Which children received the most sweets and how many did they receive? Well, actually, so these last parts are very easy because we've done all the work. So 60 sweets. In other words, it's literally just, actually, now I think about it, I think the 20th sweet we need to check as well, because we didn't do that. The k sweet is going to, yes, so we need to check 20 for the earlier part. So let's just do that. 20th sweet, that goes to 20 times 21, so 10 times 20. Oh, so that goes to child 0 as well. Okay. And so who gets the most? Well, it looks to me like 0's winning, because he's got the 19th sweet, he's got the 20th sweet, he's got the 0th sweet. Anyone else done as well as that? Nope. So child 0 wins. Just making sure. Okay, so in other words, child 0 got the 4th, 19th, 20th, 24th, 39th, 40th, 44th, 59th, and 60th sweet. So he got 3, 6, 9 sweets. That's child 0. And that should be it. So I've slightly messed that up, because actually anything in this list receives double the number of sweets. So 0 actually gets and the 15th and the 15th sorry, the 15th, 35th, 55th. So it's 12 sweets. And other people who do that, that's 1 and 5 as 1, 5, and 6 as well. Yeah, 1 child, 1, 5, and 6 also receive 12 each, because they get 4 on each loop, and there are 3 loops in total. And just to make sure this all makes sense, well, we've got 48 sweets there. Child 3 will receive 6 sweets, and child 8 will also receive 6 sweets. So that brings us up to 60. And so that's that question done. So that was completely blind. First time I've done that question. Hopefully it gives a good example of a question that, in my opinion, is designed to make you think what on earth is going on, sort of, like just trying to trick you into trying random stuff and wasting your time. Where in actuality, it really is set up, and all of the math questions are like this. They're designed such that they make you say what on earth at first, but actually, if you just translate it a bit and just rely on the earlier parts to help you and trust that they're there to help you, you should find that they're really not too bad.